Question 3a. The following diagrams represent objects which are free to move in a uniform magnetic field. Diagram A shows a current carrying conductor in a magnetic field. Okay, for each of the above objects, state the direction of its motion, if any, caused by the force acting on it, and state the reason for your choice. The first thing I'd like to do is just quickly go over the 4 right-hand rules. The first one is a magnetic field around a current carrying wire. So you have a current carrying wire, and a magnetic field goes around it where your thumb is the direction of the current, and your fingers wrap around because there's lots of magnetic field lines. Rule number 2 is for a solenoid. Your fingers are the current for a solenoid, and your thumb points towards the north. The third rule is the forces on a current carrying wire, which is what we need to look at for this question. Okay, our thumb is the cause, which is the current, direction of the current. Our fingers as the magnetic field lines, and our force is a slap. And the last rule is what we use for the last 2 parts of the question, is where our thumb is the cause. Okay, because you could pull the thumb and you get slapped. So the thumb is the cause, which is the velocity. Fingers, magnetic field lines, because there's lots of them, and we slap up for a positive charge, and we backslap because electrons are sad and we're sad and they're negative. We backslap for electrons. Okay, so back to this question. What is the direction? Well, our thumb is going to point in the upwards direction, and our fingers are going to point to the right. Okay, and our palm is going to slap down into the force, or the direction of the force. Normally what you'd see is this wire would normally be at 90 degrees, and because the wire is not at 90 degrees, it's not going to have as much force, but it's still going to have a force. So thumb going up, fingers going to the right, we slap into the screen. The direction is into the screen or into the page, and the reason, well, it's using the right hand rule, where thumb is the current, fingers magnetic field lines, and the palm is the direction of the force. The second part of this question is using the 4th rule, where our thumb is the velocity, B is the magnetic field, and our F is the force. So our fingers are going to the right, and our thumb is also going to the right. Okay, because they're both parallel to each other, and they always need to be at 90 degrees. Now the magnetic field, the velocity, and the force all need to be at right angles to each other, and because this is not, they're parallel, there isn't actually going to be a force, so there's going to be no change in direction. The charge is moving in the same direction as the magnetic field. Because the velocity and magnetic fields are parallel, and they need to be at 90 degrees to each other, it experiences no force. Okay, so a little bit of a trick question for 2. For 3, an electron's moving through a magnetic field. The crosses mean that the magnetic field's going into the screen. Okay, because you're seeing the back ends of an arrow. If you're seeing the front end of an arrow, you'd be looking at a dot which would be coming out at you, and you'd be getting scared, but you're seeing a tail which is going into the screen, and so you don't have to be scared. Okay, the dot meaning an electron, so our thumb is pointing towards the right, our fingers are pointing into the screen. Because it's a negative charge, we backslap, and so it's actually going to go downwards. Okay, if it was a positive charge, it would go up. Negative charge goes downwards. Okay, again, the reason the right hand slap rule, where you use your thumb is the direction of the velocity, the fingers the magnetic field lines going into the page, and our palm is the force of a backslap because it's a negative charge. If you got all 3 of those directions right and all 3 of those reasons right, you got an E. Well done.